Welcome to Imperatively Functional, where we demystify game development and software engineering for coders at all levels. Today, our topics are about improving aesthetics and complex movements in game design. The game we will use as a reference is Contra. Let's first talk about game aesthetics. Why it's important? Aesthetics are not just eye candy. They set the mood, enhance immersion, and can even affect gameplay. In a classic game like Contra, the aesthetics are also about nostalgia. Iconic elements included in Contra Mission 1 is a jungle backdrop, unique enemy designs, and even the waterfall is memorable to anyone who played the game. Let's first look at the original design. If you look at the game, you will notice a pixel art style with green hues for the jungle and brown shades for the soil. It's a straightforward design, but iconic. Contra also used different layers, the sky, the trees, and the ground to give a sense of depth, making the 2D games feel richer. In our example, we are going to make the background more interesting by adding parallax effect. So what is a parallax? Parallax scrolling is a technique where background images move past the camera slower than foreground images, creating an illusion of depth. Let's look at the game demo. When the player moves, we can see the background mountain, the jungle, palm tree, and also water move at a different pace, which create a depth for the game that makes the game looks very interesting. While the player is on land, we are able to shoot bullets 8 directions. The same thing can be said when the player is in the water. So there's another scenario we need to talk about is when the player is jumping in the air, we can still shoot 8 directions. This will bring challenges when we implement the movement because we don't want to use a lot of if-else statements to handle this. Just think about this. We have 8 directions and also 3 different scenarios, right? Air, water, and land. So this will create at least 24 different cases. And in order to solve this challenge, we are going to utilize a data structure called Dictionaries, which is also a map. We will talk about how to address this with that specific data structure. Let's check out the project structure. If you have watched the previous video about Double Dragon, you will notice they share very similar structure. In the main scene, we have 3 scenes: map, player, and HUD. For the player, the root nodes is character body 2D with collision detection enabled. And that is why in the map, we define many static body shapes. They are all highlighted with semi-transparent blue. That is why the player can walk on top of it. Besides these static body 2D shapes, we also have area 2Ds. They are highlighted in semi-transparent red. We have 2 of them. The first one is touch water. When the player touches this area 2D gonna emit in water event. There's also another one called death area. So this is where we capture the player when they touch the bottom of the game screen. In this case, we are going to emit a death signal so that we can play death music and also end of game music. As before, in order to decouple, direct references between the map and player, we introduce an event bus. This is a singleton. In here, we define a few signals: dead and water, exit water, shooting and stop shooting. They are pretty self-explanatory. So in the touch water area 2D, once a character touching the water, we are going to emit enter water signal. When they leave the water, we are going to emit an exit water signal. When in the death area, when the body touch this area 2D, we are going to emit a dead signal. Let's see how we add parallax background in Godot. So here, in order to create a parallax effect, we need to use parallax background node. Inside node, we can define multiple layers. And for each layer, we can add an image with sprite 2D. In our case, we have 3 layers for the background. That's why you will see we have 3 parallax layers here. There are 2 important configurations we need to be aware of. As you can see, this layer is about the sky, which move the slowest. And that is why we control that speed with scale. For the motion, we give it 0.1. And the next important configuration is mirroring. And in most cases, this should be the width of the sprite we use. So as you can see, for the second one, which is a mountain, because it moves a little faster, we give a bigger value for scale on X. And the third one is the palm tree with water. Is the closest to us, we give it 0.3. So let's look at another interesting configuration for the parallax background. So as you can see, the layer, they give it -100. This means it's gonna be way behind our main character. And because of this, everything we add to the parallax background will appear behind the player. That's why I have to create another parallax background for the palm tree in the front. And here, for the layer, I gave it a value of 1. By doing this, the player will appear behind the palm tree. Also in the map, we added a music. In order to play music, we need an audio stream player 2D node. And for the stream, we just have to drag the music we want to play here. And we just check the autoplay. When the map is loaded, the music will be played automatically. Let's look at the script for the map. Here, on ready, we load the player. We also want to connect a signal to dead. When that signal occurs, we just want to stop the theme music. Now comes the most important script, which is the player. We have 3 variables defined for controlling the speed. We also need to get the gravity so that we can apply it to the character body 2D. The player back will allow us to control the animation. Sprite is the sprite for the player, which we control when we flip it, which is dependent on which direction the player is facing. We also need to get a collision shape. This is when we need to allow user to fall through a static body 2D. We have to temporarily disable it. Death music and end music. So we need to play these 2 musics when the player dies. We also have another 2 variables to keep track of touching water and dead. Let's look at how we implement different movement without using if-else statement. The trick is using a data structure called dictionary. In dictionary, we have key value pair. So the key is an encoding of current state of the player. For example, walk up right, walk up left, down right shooting, or down. The value are another object which include 3 variables. Animation, which means the animation we need to play for this state. Position is where we should spawn the bullets. Direction is which direction the bullet should follow. Let's look at this picture to better understand how to compute the value for the hash map. The current player is walking to the right. So that is why the current animation is walking. And we use 110 to represent the current state. The tip of the gun, that's the position where the bullets will be spawned. And the arrow pointing to the right should be the bullet moving direction. After we figure out everything, we encode all this information, then we get this value. Next, let's quickly go through the code and I will show you how to get the key for each state. So in Ready, we set up the events listener we are listening to, and enter water, exit water, and dead. When dead happens, we will call this underscore dead function, and we set that to true, and we play dead music, and also we ask the system to stop shooting, and also when dead music is finished, we are going to play end music for the game. So inside physics process function, we only execute the logic when the player is not dead. So if the player is in the air, we apply gravity to the y direction. So the tricks we use to compose the keys for each different state is using input get axis, UI left, UI y, UI right to get the value for x, and use input.get axis, UI up, UI down to get the value for y. All the possible values for x directions are -1, 0, 1, and the same thing for y directions. For x, 1 means moving right, -1 means moving left, 0 means no movement. For y, it's a little bit different. 1 means down, -1 means up, and 0 means no movement. When user play jump, if the player is in the water, we are going to give it a smaller velocity. Otherwise, we are giving it a regular velocity. If the player is lying down on the ground, and user press down and jump simultaneously, we would allow the player falling through that rock. We have to disable the collision shape, otherwise it will keep preventing the player from falling through. And right after disable this, we need to re-enable it after 0.1 seconds. That's why we have a timer, and the timeout is 0.1 seconds, and it's one shot automatic start. And when the timeout happens, we just re-enable the collision shape. So the next time one player comes back in, it won't fall through again. The key is the key for the animation map. And the way we construct it is a concatenation of both x direction and y direction. Sometimes there's no x movement. That's why we have a 0 at the very beginning. If that is the case, we still need to know which direction the player is facing. That's why we append a -y if the player is facing left, otherwise 1. This will give us a general idea on how to control and compose the key, but we are still missing something. Because we have 3 scenarios: in the air, in the water, and on the land. So far we only takes care of the on land scenario. We also need to distinguish it from the water and in the air. That's why when it's in the water, we give it 0 suffix, and when it's in air, we give it 2 as a prefix. Once these are all done, the key is being properly calculated. Now we are able to play the right animation by calling playback travel animation key animation. So when we shoot the bullet, since the key is already been calculated, we are able to pass along the right position for the bullet and the right direction for the bullet inside of this emit signal method. We have a timer, shooting timer defined in the player, which is used to listen to this event. Then it can create bullet for us. Last thing, let's look at that timer. In the player scene, we have a timer. The responsibilities of this timer is to listen to shooting event and stop shooting event. When stop shooting event happens, it will stop shooting. When shooting event happens, it's gonna create a bullet and add it to the scene tree. So in the shooting event, we have a position and the direction information. We can use these two information and pass it along to the bullet instance. In order to create a bullet instance, we need to preload a bullet scene. And for the bullet scene, it's pretty simple. We only have to implement a physics process method. Here we constantly update the position based on the speed and direction value. And also we add a visible on screen notifier 2D, and this gonna free the resource when the bullet go off the screen. Congratulations, if you have gone this far, that means you finished watching this video. And don't forget to hit the subscribe button and ring the bell for more content.